So now that was a bit technical background, a little bit more interesting here. So what is air scrubbing? Here's two images. If you guys are probably not familiar with it. There's two approaches. We can either build a box and we can ship it to a farm and we can put it on the end of a building, plug it in and run it away like that. Or we can integrate it into a building like this. Now, this is an extreme farm. It's a pig farm fairly close to here, 20,000 pigs in here. And what you've got is you've got 2 floors of pigs in 5 separate buildings. And basically they're ventilated through here. The air goes through the pig rooms, then out through this corridor. This is an extraction corridor into the air scrubbers here, and then blown out into the atmosphere once the air is cleaned. This particular farm itself, we also have energy recovery on it, and we're generating about 3.2 megawatts of energy that we reuse to heat, warm or cool the animals during peak periods in climate. So this in effect, not only is it a pig farm, but it's like a small power station that is fueling, as it were. Okay. So they're the 2 types of air scrubbers. What does it look like inside? Well, here's a very simple picture. If you have to picture this, where we're facing from the right side is the air coming out of the building, and basically, very simply, the air goes into what we call a kind of washing area, and then it gets blown up through the washing table. So if you picture this, it's an expanded out without any walls on the side of it. So the air is obviously trapped in there, gets blown through. Above the washing table, there's a sprinkler system which is spraying either chemical water or biological water across this washing table. And then the contact time here on this table is where the cleaning process is done. So in other words, with a chemical air scrubber, the ammonia in the air will bind with the sulfuric acid in the water, right? The dust will get collected by the wash water because it won't get through the wash water, and the washing process itself removes some of the odor molecules in the air. A lot of the odor molecules are also bound to the dust, and that's how we do the cleaning process. The whole thing is controlled by a computerized system, which is basically made up of a pump system. So basically the water is getting pumped around here, sprayed over the washing table. There's a filter to make sure none of the nasty gunk that comes out of the chicken or the pig house that finds its way into the wash water mucks up the pump. And then it's self-monitoring, so we're checking constantly conductivity. So that's the electrical charge within the water, which gives us an indication of the salts building up, because of the end result of ammonia and sulfuric acid binding together is we produce ammonium sulfate, which is a salt. So we're monitoring the buildup of that, because when it gets too high, we then have to remove it to some wastewater tanks for reuse later. And then so the whole thing is self-regulating, and it's important that it does that because that provides an optimal washing process. Okay, it's a very, very simple system. And this is what it would look like in situ on a building. This is actually a farm in Welshpool in Wales, where the regulations are quite strict. Basically, you have 2 chicken houses here, 50,000 birds. The air is coming down the sides, being blown through this end, and then this is the air scrubber room at the end of the building, and then the clean air gets ejected out the top of there. And this is a kind of schematic of the inside of it. And as you can see, it looks very similar to the previous drawing, where you've got the washing table, obviously slightly bigger, the washing area, the sprinkler room down there, sprinkler section, and then this is what we call a drop catcher. It's used mainly because there is moisture in this air to trap any residue, any salts that might find their way out through the exhaust. So just make sure the air remains super clean. Okay. And importantly, and certainly for regulation, that these systems are monitored. So these systems are all connected to the internet. We're monitoring them 24/7, and I won't go into the fine details of this, but by looking at those measurements such as the pH of the water, the conductivity, etc., and knowing that the air scrubber has been designed to meet protocol, then we can confidently say that the emission air going out of the scrubber is clean and it fits within the regulation. On the whole, our air scrubbers, because they're slightly bigger than needed to be, perform slightly better than expected. But of course, if not maintained, they fall foul like any technology would do. So that's basically how we go about cleaning the air. I mean, obviously, as a byproduct of the process, we're producing a lot of wash wastewater, as it were. This wastewater actually comes in two forms. I mean, if it's a biological air scrubber, we produce ammonium nitrite, which has a pH of around 7, so it's pretty neutral, and that can, both the wastewater types can be used for fertilizer, and this could then be used to, you know, if regulation permitting, can be used to treat land for growing crops, etc. So it's not exactly waste, it's actually organic fertilizer, okay? And likewise with chickens, where we tend to use chemical air scrubbers, we're producing ammonium sulfate. The pH there is around 3 to 4, probably the same level as a Coca-Cola or an apple, so it's not super strong pH, but it's there, and that probably would need to be treated before you put it onto crops or land. But again, it's an organic fertilizer that has a value. So nothing in this process goes to waste.